Welcome to BE 110 Continuum Mechanics. Here we are at the TED page for this course, and if we go to course information, you'll find out about important information on the class. My name's Andrew McCulloch. I'm Professor of Bioengineering, and my office is in room 231, Palfoot Bioengineering Hall. Classes will be on Tuesdays and Thursdays in Warren Lecture Hall, room 211, but we will also be having tutorial sessions on Mondays and Wednesdays. We have two outstanding graduate student instructors, both of whom are new PhD students in the graduate program, Kim McCabe and Will Valdez. I'll have them introduce themselves in a second, but I can tell you that both of them are very knowledgeable and capable in continuum mechanics. They've both been taught by outstanding faculty at Yale University and University of Utah, who we know well. In fact, their former mentors were both UCSD bioengineering students themselves. So let me take a moment to have Kim and Will introduce themselves.
Hi everyone, I'm Kim McCabe and I did my undergraduate in bioengineering at Yale University.
Very good.
Hey guys, I'm Will Valdez. I went to University of Utah.
Kim and Will will be holding tutorial sessions on Mondays and Wednesdays, and these sessions will be important for you to attend, at least one of them a week. They'll be reviewing material in the class and helping you with the homework problems. Continuum mechanics is a general introduction to the mechanics of continuous media, so that's both solids and fluids, and it's an advanced subject. We will be introducing new concepts, new notations and theories that apply to a large range of engineering problems. And the reason that we use this very broad and general approach is because biomechanics is not limited either to solids or fluids or specific types of structures or materials. And so we really need the full breadth of continuum mechanics to prepare adequately for biomechanics, both for BE 112A and BE 112B, which cover biosolid mechanics, cell mechanics, biofluid mechanics. So some of the key concepts that we'll be covering in this class include tensors and introducing tensor index notations and tensor object notations. We'll talk about kinematics, motion, strain rate, stress, constitutive models for stress in solid and fluid continua, and then we'll build up to deriving the field equations for the conservation of mass, momentum, and energy in continuum mechanics. We'll be solving problems, and we'll emphasize the role of engineering design in the homeworks. Even if the homeworks themselves don't include specific design assignments, there'll be design-oriented questions. Those assignments will be posted at this website, and will usually be due the week following posting. I'm going to try something new for the first time in this course by flipping part of the course. So what that means is that before many of the lectures, there will be a video like this one online available that you will need to review prior to coming to class. By doing so, that will give us more time in class to explain the concepts that need more time and to work more on examples. We won't be completely flipping the class, so these online lectures won't be an hour long. They'll only be 10 or 15 minutes probably, but they'll allow us to save time in class to answer questions, to discuss concepts, and to work on problem solving. To help in that process, we're also going to use clickers. I hope that all of you still have your clickers from BE1. If you don't, any kind of clicker, iClicker will do, other than the iClicker Go apps, which unfortunately are not yet supported by UCSD. But the old generation clickers or the new iClicker 2 will be suitable for this class. So here's a typical iClicker 2. It has an LCD screen. You don't need that. All we really are going to use is the 5 buttons. The way we're going to use the clickers is at the beginning of each class, following a homework or following a posted video, I'll ask some questions. First few will probably be fairly simple, but then we'll start to ask more advanced questions, and at that stage, after you've voted your initial score, we'll have you discuss the questions with your neighbours and possibly change your vote. And then depending on the answers to these questions, we can spend more time to explain and focus on those concepts that need the most attention instead of those ones that everyone already understands. There's no required textbook for this course, but there are a few books that if you're interested in, you could potentially use. In fact, there are many books on continuum mechanics, and if you find any book on continuum mechanics that you like, it will probably be more than satisfactory for this course. But as I said, none is required. If you do want to buy a book, this book by Humphrey and DeLange, An Introduction to Biomechanics, Solids and Fluids, Analysis and Design, is the book that is supposed to be required next quarter and in the spring for BE 112 A and B. So provided the instructors of those courses stick to the plan, you'll be buying this book anyway, and so if you can find it now, it does have some introductory review material on continuum mechanics. There are a lot of used continuum mechanics books around, and the two that relate most closely to this course are Y.C. Feng, First Course in Continuum Mechanics. This is the second edition. The third edition is blue. The good thing about this book is it has lots of examples in it, many of which we'll use. I might even assign some homework assignments out of it, but if I do, you won't need the book. I'll reproduce them. But the notations that I use are actually more closely related to this book by H.A.M. Spencer, called Continuum Mechanics. The notations in this book are much simpler, cleaner, and consistent, and that's why I prefer them. But this book isn't very good as far as examples and motivation goes. It's a pretty thin book, as you can see. So, and it's out of print. But if you can find a used copy and you would like a book that follows the notations that I use, then this is the way. Okay. So here is, scrolling down, here's the topics that we'll be covering during the quarter. We'll start with an introduction in which we'll talk about the continuum concept, what a continuum means, and what constitutes a continuum mechanics problem. Before we can get too deeply into the subject matter, we really need to review Newton's laws of motion and the free body diagram so we can work on some basic problems in mechanics, because although continuum mechanics is different from statics and dynamics, it builds on the equations that we used in statics and dynamics. After we've spent a bit of time working on reviewing the mechanics of bodies in static equilibrium, we'll then do a review of matrices and matrix algebra so that we can introduce the idea of tensors. And tensors is a generalization of the idea of vectors with which you're already familiar, but it does involve some new notation. And then we can start to show you the notations and formalisms for properties of tensors and operations on tensors, including tensor calculus. Next, we'll talk about the stress tensor, which is the single most important tensor in continuum mechanics. We'll define it and we'll give physical examples and derive the equilibrium conditions for stress. Then we'll talk about motion and displacement and use this to derive the deformation gradient tensor and strains, analyze strains in solids and rates of deformation, vorticity and spins in fluids. For the next few lectures, we'll talk about conservation laws, conservation of mass, momentum, and energy, that'll take us through to Thanksgiving, after which we'll start to look at some examples of particular types of materials, such as Hookean elastic solids and Newtonian viscous fluids, so that we can put them all together and set up some simple boundary value problems in elasticity and viscous flows. And that will bring us through to the exam. So, a word on grading. I've dropped the midterm from this course because we'll use clicker quizzes. There won't necessarily be quizzes every day. I'll try and have a quiz after every homework and after every posted video. And depending how we go, if we feel like we need a midterm, we'll have a clicker midterm. But the points will be all out of this 25% towards the final grade. And the way we'll be grading questions for the clickers is that you'll get 5 points for the correct answer and 3 for answering the questions at all, and you can drop your worst 2 session scores during the quarter. So homework and design assignments will therefore take up a little less of the total grade than they would have in the past, 35%, because some of that grade I've put into the clicker scores and we'll review the homeworks during those quizzes, and then the final exam will be 40%. I've written some material here about grading policy and late homework. In general, we encourage you to get the homework done even if it's going to be a little late. It's up to the TA's discretion as to whether you'll receive a penalty for late homeworks, because they're the ones that are disadvantaged by late submissions. I need to remind you about academic integrity. It's okay if you work together to study, but homeworks that you hand in must be your own, and because of the nature of this course, they should also always be only handwritten. And it also goes without saying that you must only use your clicker. You can lend your clicker to someone else in another class, but you can never lend your clicker to someone in this class, and you obviously can't have someone else take your clicker to class when you're not there. So I think that's all I have. We'll look forward to seeing you in class.